Okay, we're in problem number 1. It says use the shell method to compute the volume obtained by rotating the region enclosed by the graphs as indicated about the y-axis. So what I want to do is go to the whiteboard. I'm going to try to visualize the problem and set the integration up. All right? So let's go to the whiteboard. Again, we're doing problem number 1. And number 1, one of the curves, I'll just write down y, by the way, is 3x minus 2. And the other curve is y equals 6 minus x. And then it says, x equals 0. So let's just see if we can understand what the region is. It says use the shell method, compute the volume obtained by rotating the region. So I want to see if I can understand the region. So the first thing up is I need to graph each of these lines separately. So I'm going to say this line here, pretty easy to do. It's minus 2. That's the y-intercept, by the way. And it's got a slope of 3. So what does that mean? 3 over 1. That's the slope of 3. So up 3 over 1, thereabouts. I'm going to put this over here. Again, this is just a rough picture. All right, that's done. What's the other one going to be? 6 minus x. Now, what do I know about that? It's 1, 2, 3, 4, 5, 6, and it's got a slope of minus 1. So before I do anything, I want to point out there is a point of intersection. If I'm looking at that, there's definitely a point of intersection. So what do I get? 3x minus 2 equals 6 minus x. Let's see, you'd get 8, add 2 to both sides, add x to both sides, you get 4x. So it occurs at 2, all right? So I'm going to put over here, the point of intersection is when x equals 2. What would the y be? 4, all right? I'll say somewhere over here about. Again, not the best pictures, by the way. So x equals 0 is the y-axis, so I see the region right there. All right, I see it. All right, let me put the points down for you. This point over here is 2, 4. This point over here is going to be 0, minus 2. This point up here is going to be 0, comma 6. All right, now, someone says, I can't even remember what they want me to do. This is what's so nice about things written down. You just read the question over and over again. What are they going to do? They want you to use the shell method, and we're going to rotate about the y-axis. So what I want to do is I want to put down a rectangle. And the easiest rectangle for me to do is something like this over here. All right? Now, what I start to realize, if I did that, I'm going to put a little black box now. If I were to rotate this thing about the x-axis, I'm basically going to get like a shell shape, right, or what some people refer to as a can, which basically I'm going to lay it out flat now. In other words, it will be like this over here, but I'm cutting it and laying it flat. And to me, this looks like a box. The differential over here is dx. All right? So there's a couple of things I need to know. I need to know the length around that, which is just circumference. And that really is going to be 2 pi times the radius. Well, the radius just corresponds to the letter x. All right? Now, I want to do the height of it. It's over here, because I need 3 dimensions. It's going to be upper minus lower. All right, what's the upper curve? Well, it's 6 minus x. What's the lower curve? It's 3x minus 2. Let's write that down. So what are you going to get? Well, 6 minus a minus 2 is 8. Minus x minus 3x is minus 4x. So the volume of this box, let's write this down, 2 pi x, 8 minus 4x. I'm just taking these dimensions here, and dx. All right, let's talk about where the x's are going from. They're going from 0 up to this point of intersection, which occurs at 2. All right, this is a milestone over here to reach that. All right, now certainly my encouragement here is when you're studying, it's nice to have someone looking over your shoulder, and you have the answer key right now. Now, before I do that, I want to just simplify this a tiny little bit before I look at the answer key. I'm going to pull out, you know what, from these two, I'm going to pull out a 4. And 4 times 2 is 8, so I'll say 8 pi. 0 to 2. We're left with x. And if I pull a 4 out from this, let me put out what I mean. That would be 4. That would be 2 minus x. What are you going to get? I'm sorry, I didn't mean to say 4. I pulled the 4 out already. Let me go over that again. I spoke and then I daydreamed. Whoops, that's way too big, isn't it? Okay, let me point out what I did. I pulled the 2 out, I pulled the pi out, and I pulled the 4 out from this over here. If you pull the 4 out, what would you be left off with? By the way, 2 pi 4 is 8 pi. If I pull the 4 out, I'm left with 2 minus x. But you have an x there. What would that give you? 2x minus x squared dx. All right? What am I going to do now? You know what? Let's look at the key. Was I able to reach that milestone? I do see it. Again, I'm just looking back over the notes. Let's go to the next step. Can I do the integration? I think so. What do you get there? Well, you get 2x squared over 2, which is x squared, minus x cubed over 3, 0 to 2. Looks like an easy integration, easy evaluation. What do you get? 4 minus 8 thirds minus 8 pi times 0. What do you get here? Let's write this down. We'll look at the key in a moment. Common denominator 3. Get 12 minus 8. Let's see, common denominator, denominator of 3. 12 minus 8 is 4. 4 times 8 is 32. So 32 pi over 3. What I'm going to do, next milestone, was able to do the integration, evaluation, and we're good to go to the next question. Thank you.